This is Samuel Jr. I would like to welcome you to this new chapter of the channel. There have been many changes after 2 or 3 years without posting any video. I'm finally excited to start over and continue with this. So basically, changes that have happened where I changed the name of the channel because I'm planning to start a Kickstarter where I'll be selling some electronic products that I'll develop along with you guys, and that will be open source. And why I'm doing that is just so that you can learn more, I can learn more with the time, with experiences and with mistakes. So I'll be putting some products in market for fairly cheap, and you guys can purchase and see whether it's good or not. You can try to modify it yourself. You can suggest on to me through the comment section, and I might be putting up an email where you can just put some details where specific things that you like to do or suggest, and that's all. So today in this video I'll be going through some things that I will be focusing on for the next days. So I've made this schedule basically. So this is basically what I will be doing for the next weeks or months. We don't know how this will go. Since I'm starting, I don't want to push myself so much. So I'll start with this. This is a PCB design that I've made recently, and I'm going to be printing it. So I will be starting with this project. So basically it's gonna be a smart cooker, kind of a pot that will have Wi-Fi and probably a app that you can see whatever is happening on the pot. You can turn it on, you can turn it off, something like that. And next I'll be going through the development of a CAN based IO multiplexer. So this is also a PCB design that I'm going to print. I already have the design ready, and in this I'll be showing you guys how to start the PCB designing. Basically I'll just design is ready, so I'll be showing you guys my approaches, what was my thought process going through the design, and then I'll be explaining some parts of the schematics, and then I'll move forward to the PCB design, my approaches, and then I'll be move forward to the assembly of the PCB once I get them. And from the assembly of the PCB I'll be just testing the performance because I still have to write the code for it, and you'll be with me in this journey how to develop all of this. And next, in the further future, we'll be doing a CAN based stepper motor driver. So that is a quite a involved project, so I'm really interested in doing that, although I have to plan it out properly. And then we'll move to the plant caretaker or mini greenhouse. I was looking for a proper name. And funny fact, I had my mic off. I recorded this whole video like few minutes ago and the sound was off, so I had to turn on the mic and record it again, which is now the second time. So that's why I'm going through everything really quickly. And in this video basically just want to go through some designs that I've made, and I want to know which kind of content you guys want. If you guys want to learn how to make a PCB from scratch and then we can move into this, or you guys can learn what kind of videos you want, like basic electronics and or more involved electronics like PCB designing, or just basic electrical. And I've been to Baja. If you guys don't know, Baja is a automobile competition where student teams make off-road ATVs, and those vehicles are then competing there. And here we have e-Baja, which is electric ATV. So I've developed a full ECU for that, and I have the PCBs here. So if you guys want to know what was my thought process, how to develop such embedded PCB, and I can show you all the versions also, like my first PCB, second PCB, for this same process. I've been there for 3 years, so I developed three PCBs, three ECUs. Three PCBs, no, they were more than three, but the combined system was like three ECUs or three electrical systems for that vehicle, for those vehicles. And if you guys want to know my thought process and how I approached it, such problems, we can also do that. And we can also do videos like you give me a problem statement on the comment section, and I can just show you how I can approach that. And then we can have a more involved discussion where you learn more, I learn more, and everyone is happy. So now I'll just go to this design really quickly. I don't know which design I had left it. Oh, I had the IO multiplexer open. So let's just start with this. It's fine. So this is KiCad. It's the software that I use for PCB designing. So open source software, very good. This is the PCB, and I'll just jump into this. So here I have the PCB. It's a two layer PCB. I try to keep it simple so that we can put it for chip on GLC PCB. And it's a bit more evolved PCB. That's why I'm not going through it first in the following videos, because these have more things going on, like controlling 12 volts digital outputs, controlling receiving 12 volts inputs signal, and ADC in 5 volts, ADC using thermistors to measure temperature, and then PWM in 12 or 5 volts. You have the option for that through this, as you can see here, PWM level, and CAN. So we have CAN communication here. So basically this can work as a PLC and also can work as a simple IO multiplexer using CAN. So in IO mode, IO multiplexer mode will be basically you send some CAN commands and the processor will react according to that. So for example, turn on output number 1, so it'll turn on output number 1. Or you can, as a PLC, it will work like based on this input, do something at this output, or do something or at this output, something like that. And for example, based on the temperature, increase the speed of the fan with PWM. So you guys can see where this is going. And this PCB, I designed it recently. As you can see here, the new logo flashing on. Yes, and that's basically it for this PCB. I won't go through it so much because this is a more evolved PCB. And I'll jump back to the first project that we're going to do, which is the previously it was Bluetooth, that's why it's BT here, but it's now Wi-Fi based. So I'll explain why in the following videos, but yeah, it's now Wi-Fi based. So basically in this PCB we have AC going on, so I'll not suggest anyone to follow this as a tutorial because AC is dangerous and AC can kill. So although after I finish this and I get the printed PCBs, I can provide one or two to some of the you viewers, and you guys can test it out and maybe make some improvements and let me know later on. This is how we all evolve. So here we have, I try to separate in the schematics as well. This is the all AC. We have a little bit of DC here going on because I wanted to make sure that the load, the AC heater, won't take power even whenever it's not needed. So I put it a relay interrupting the circuit over there. And here we have a current sensor just to give a feedback of how much current is consuming based on the PWM input that is being given here. And I can write some logic based on that to make sure everything is working properly. And we have here thermocouple. We can use K-tap thermocouples, 4 of them. And here we have the microcontroller, which is the main microcontroller, which is STM STM32 F103C86. And here for the Wi-Fi we have the ESP8266 12F. So I'll be teaching how did I find out like which components to use, why these components, and then how I got to know how to use all of them. And I'll be showing you guys how I check 10-15 times my circuit and how do I check it. Because for example, these I've used this same design in 3 4 5 PCBs and I've tested it. This is totally fine, so for sure I won't test it, I won't check this again. But if I go like for this AC part, very rarely I use AC, so I'll be checking it multiple times, and I already did. So now I'll go for the PCB. So here you have the PCB. So I took an interesting approach in this design. So basically, as you can see, the PCB has a split in between. So this area, this side is the AC part, and this part is all DC and analog signals. So if you can see here, I put a sign of danger because yeah, it's AC, and if I'm giving this to someone to test it out, so I have to make sure they are safe and they don't touch it. And oh, also for this PCB, I'll be showing you guys how to design an enclosure for it, how to design an enclosure for all your PCB designs. So because this will be enclosed, this will be embedded or incorporated in a system that already exists. So I'm just trying to upgrade, modify it to work in such a way that can make our lives easier. So this is the PCB, and I can show you the components over here, everything. So this is a zero crossing detector for our microcontroller, and you can see one side is AC, one side is DC. And likewise here, this is just a simple full bridge rectifier for our DC signals. Oh, actually this is the triac driver, sorry, this is the triac driver, and this is the zero crossing. So this is just for the zero crossing, and this is for the triac driver. So one side is AC, one side is DC, and this is fully DC. Just this side is AC to DC here through the full bridge rectifier. And I have some jumpers here, jumper resistors, so that I can jump some signals. Like for this relay I have to turn it on, so I have this jumper over here. And I might be changing this for a smaller resistor. I'm just looking what is available in market right now, and then I'll see. And yeah, that's basically it. And I have some screwless connectors here. I'll be using screwless connectors. These ones, they're basically, they have a spring where you just press it and put a connector, and that's all, and it locks in. And this is the main fuse for the AC in DC booth. So that will be it. In this PCB will be using a OLED display using I2C. We have also here the programming for the STM32, and we have the encoder pins for the menus and all. And we have a lead. I'm trying to use a lead sensor for this project, so to know whether the lead is open or off. And yeah, that's mostly it, and I hope you guys will enjoy this new journey. And that's all for today. Thank you for watching. See you on the next time.